Hello everyone, hopefully you can hear me. So this is going to be our first lab. And let's first start with a couple of reminders. So I guess you all have the course website, so it's accessible through this link. I also sent you a link today, and you can access the labs, the homepage for labs from there. So we are going to have 6 labs in total, and usually we were having these labs not at every week, but because of the summer school, we are going to have a lab at every week. So for 6 weeks we have these labs, and labs are going to focus mostly on the project. So we are going to discuss some topics that you are going to need for the project. And if you look at the lab homepage, these are the previous semester's recordings. We also have the materials here. If I update some of the materials, I can send a mail about it. But we are going to first start with how to use Draw.io to create ER diagrams. So today's topic is going to be creating ER diagrams using Draw.io, and it is also going to be the first stage of the project. But we are going to first also start with some reminders about ER diagrams. So I have this slide set here, and this slide set is also available on the website, so we are going to go through that. Let's also talk about the project. So we have 5 stages of the project. So for the design stages, what we expect you to do is to come up with an ER diagram based on the description of the project. So we are going to actually have 2 chances to refine the ER diagram, or let's say one chance to refine the ER diagram based on our feedback. And then we start implementation, and we would like to use Python for that. We are going to create SQLite databases. So there are different kinds of database systems or programs that we can use. So in the lab we are going to use SQLite with Python. In the implementation stages, these are going to be some small demos, and at the end you are going to have a final demo, and you are going to implement all 3 scenarios. So for each project topic you are given 3 different scenarios. And today we are going to start with how to draw ER diagrams, and we can use a pen and paper for that, but using a tool makes our lives easier. We are going to introduce the Draw.io for that. It's a general software for drawing diagrams, but we are going to use it especially for ER diagrams. Then in the second lab we are going to start using SQLite Studio. It's a software to implement SQLite databases. So we are going to create our tables there. We can populate our tables. We can run some test queries there. Then with lab 3 we go into actually using SQL queries. So our focus is going to be how to use or write some SQL queries to retrieve data or to modify our data. And starting with lab 4 we are going to go into Python. We can import this database that we create in SQLite Studio, and in Python we can also run SQL queries. And we are going to then start implementing a graphical user interface. So labs 5 and 6 are going to focus on that. How can we create some graphical elements to interact with the user? So usually we had some separate labs for showing the implementation stages, but because of this online courses we do that if it is required. Otherwise we don't have lab 7 and 8, and our schedule is going to be as it's on the website. So why do we use a database? So let's remind that to us. So we can store our data in a text file as well, right? In a database mostly we have some columns, and rows our entries are corresponding to different instances of data we have in our database. For example, we can insert a new student to our data. We can check whether a certain student is there, if we are storing the students in our database, we can delete some data from here. And instead of a text file, using a database makes some operations easier. So instead of, for example, in here, if it was a just text file, we need to scan all the lines to find out whether there is a student with ID 312 in there or not. So if we are to insert a new student, and if we require this ID to be a unique number, then again we need to check whether it exists in our data or not at first, before we try to insert it. So in text file, we need to scan the whole file. But this is going to be inefficient, because in a database, usually we need to store lots of data, right? There could be millions of students, and for each operation, if I need to check everything, then it's going to be inefficient. It will be slow. And with database systems, we have some quick access mechanisms. For example, using a B+ tree, for example, you are going to see such algorithms or mechanisms later in the course. You can quickly find out whether there is a certain ID in the database or not. Other than that, in just a text file, so we can store the data, but in the database, we can store relational data, right? By the way, if you need to ask something, anything, you can like interrupt me and ask that during, don't hesitate to do that. So in the database, we can store the relationships as well. So let's say we are storing a bunch of students, we are storing a bunch of courses, and there could be a separate table to store the information about which student is enrolled into which course. So this is going to be a relationship in between two different tables. And with a database system, we can ensure that while we are trying to insert some data into this relationship, for example, for the enrolled table, we need to store the ID of the student and the course ID of the course. So from the student side, I need the ID. And while I'm trying to insert a new data for this enrolled table, it is going to make sure that this ID belongs to an existing student. For example, I will not be able to type for the ID 100. So there is no student with ID 100. And if I were to try enter it, it is going to say that, okay, you are trying to insert this student, but there is no such student, so please check your data, etc. So with a database system, this becomes easier. And a database system can be managed by multiple users, and these are going to be called as transactions. So for example, multiple users are trying to manage or update, modify the same data, and it is going to handle these cases with certain algorithms. So you are going to see such things at the last stages of the course. But for example, if I'm trying to insert a new student with this ID, and at the same time some other user is trying to modify the same data or a related data, this should be resolved in a way that it will prevent any failures or mismatches. So in a database, we can also design queries to show or update the data in different ways. So some example queries could be like that: list the name of the students who are enrolled in more than 5 courses. So if it was just a text file or a simple data file, it's hard to come up with the implementation of such queries, but with a database system, these are going to be very easy with SQL. So some other example: increase the cost of cars that are produced in the year 2001 by $400. So we need to update something. We have some filtering about the year, and we have the increment amount right here. Delete the students who have a grade less than 5 in at least 2 courses. So for such things, we can use the database system. And the database design could differ. So to solve the same problem, we can come up with different equivalent designs, and some of them would be more efficient. Some of them could be storing some redundant data. So these will be some important concepts. For example, in the student table, I had the name and surname of a student, but while keeping the relationship enrolled, for example, I really don't need to store the name in this table again, right? If I know the ID of a student, I can easily find the name of that student. There is no need to store the same thing in multiple different tables. So some designs will be better, and some designs might store redundant elements. And to design our database, we are using the entity relationship diagrams. So it is showing the relationships of entity sets stored in a database. So in here, what we call entity is going to be an object. For example, the student could be an entity. And an entity set is the collection of these similar entities. So one instance of a student is called entity. And in here we have the student entity set. So this set is called the entity set. The entities can have attributes for their properties. For example, in here, the student object has the ID attribute, name and surname attributes. So we would like to define these entities and their attributes. And we also would like to show the relationships in between them. And ER diagram is going to be the way to do that. And there are some different styles of ER diagrams. So we are going to introduce one of the styles in the class, and we expect you to use that style in homeworks, in projects, and all the course related subjects. So let's say we are given this database description. In the projects, we are also given such descriptions, and we need to convert this or create a design using an ER diagram out of this description. So I'm going to focus on parts of it. So let me go through them. So in each element, so I have some parts of that text. So I'm not going to read it through in this slide. But let's also remind us about some elements and how we show them in the ER diagram. So starting with the entity set and the attributes. So this is the most basic one that we have in the ER diagram. Entity set is the collection of entities that have the same set of attributes. So for example, if I'm storing an object, I expect that object to have the same set of attributes. For example, for a student, I should always have the name, always have the surname, etc. if that's an attribute. So attribute is the properties of entities. So for entity sets, we use the rectangular shapes, and the name of the entity sets is written on top of this rectangular shape. And for attributes, we are using the ellipses. And these ellipse shapes should be connected to entities. So we are connecting them with solid lines, simple lines. And some attributes could be the primary key of an entity set. So for example, for entity 2, attribute 2 is the single primary key. And sometimes the primary key could be a composite one. So multiple attributes could contribute to a primary key. In that case, we underline all those attributes, all those different attributes. So with that knowledge, so if we look at the so maybe the first word is, this first sentence was not included there. Let me first start there. Maybe you are going to design a database for a school. So since we are designing this database for just one school, the school is not going to be part of our ER diagram. So the whole ER diagram represents our school. The whole system is going to be for the school, but we are not really storing multiple schools, right? I don't need to include the school in the ER diagram. But then continuing with that, you are going to, okay, this was also included there. We are going to design it for a school. Users of the system have a unique ID number, name, surname, and password. So I know that from here, I need to store some users in this database. And for a user, I need to have a unique ID number. So one attribute there. Name, surname, and password. So these are the different attributes that belong to a user. Therefore, I connect these attributes to the entity set. And since the ID number is unique, I also make it the primary key. And to show that it's the key of this table, I underline the attribute name. So for entity sets, we are using rectangles. Attributes are using ellipse shapes. And one attribute should be connected to the entity sets using a solid line. So if we have an attribute, it should always be connected to some entity sets. Or there is the also alternative. We can also connect an attribute to a relationship as well, but it should be connected to just one thing. So that's one of the things that is important. And we are not connecting the attributes together. So attributes should be connected to a different kind of shape. We also have the is a relationship. So it defines a hierarchy. And for example, in here we have a parent entity set with some attributes. And if we are using the is a relationship, the entity sets that are below the triangle shape are going to be the children of this parent. We can have only one parent in ER diagrams. And the child entities are going to inherit the attributes of the parent. So in child 1, for example, because it's a child of this parent, it's going to also have attribute 1, which is the primary key, also attribute 2 and 3. Additionally, childs can have their own attributes. So for example, for child 2, we have all these attributes coming from the parent, but we also have these additional attributes 5 and 6. And for child 3, we have this additional attribute 4. And if we are using the is a relationship, we expect some sort of difference in between these child. So if I'm not introducing any new attributes or any new relationship capabilities, then it's not very meaningful to use a is a relationship. For example, in that case, for example, let's say I have students of different levels. So the levels are called beginner, intermediate, and advanced. And in this case, if I'm using the is a relationship, it doesn't make much sense because I'm not storing any additional data for these different kinds of students. They don't have additional relationships as well. So it can be converted to an attribute in this case. For example, for a student, instead of having the is a relationship and keeping the entries in different child tables, I can just store some level attribute in a student, and I can write it as a string, as a text, for example, whether this student is a beginner, intermediate, or advanced student. So this is another example here on the right side. In here, what we have is two levels of is a relationship. So we have the user as the parent, and there are like managers and managers and workers. So manager is a type of user, and for a manager we have the additional account number and department name. And worker is a type of user, and for workers we are storing salary. And there are two different kinds of workers, for example, researchers and technicians. And for researchers, for example, we keep the university name, but for technicians, we are keeping the specialty of that technician. And maybe for these different childs, we can define different relationships as well. So that's also one possibility. For example, we can say, okay, users can have cars, then manager is also a user. Manager can also have a car, for example. But let's say if we define a relationship for the researcher, if we are saying, okay, researchers can work on projects, then technicians and managers are not going to be able to work for a project. Only researchers will be able to work for a project. And going back to our description, it was saying that a user could be a student or a teacher. So it's saying for students, you should also store an amount of scholarship. So from here, I know that there are two kinds of different users, either teachers or students. And for students, I need to keep some additional data. I need to also store the amount of scholarship. So the user is the parent side. Teacher and student tables or entity sets are the child, and they are below. So was there a question? I guess that was a mistake. Okay. So for the is a relationship, the parent should be at top and we connect the children at the below side of this equilateral triangle. So that's one thing we need to be careful. So if you connect by mistake multiple things at above the triangle, it doesn't make sense. There can be only one parent in ER diagram. So with relationships, they are shown with diamond shapes. We are keeping information about multiple entity sets together. We can relate two or more entity sets. There can also be self-referential relationships. So the same relationship can be connected to the same entity set with more than one link. And relationships as well can have their own attributes. So in this case, for example, between entity 1 and entity 2, we are defining this relationship, and for that relationship we are keeping the attribute 5, for example. And we are going to see it later on, but actually what this diamond the links between the diamond shapes and entity sets mean is that we actually need to store some foreign key inside this relationship to be able to refer the entity. So if we consider any entity set, to be able to find a unique entry in an entity set, we need to know the primary key. So the primary key is the underlined attribute or attributes. So for example, to be able to find a unique row here, I need the attribute 1. I need to know the attribute 1. And for entity 2, for example, if I know the attribute 3, I can find a unique row inside that set. And the relationship means that I need to store this attribute 1 to refer to entity 1, and I need to store this attribute 3 in the relationship to be able to select entity 2. So the primary key is of the connected entity sets. We are going to use them as foreign keys inside the relationship. And these foreign key attributes are already indicated through the connecting lines. So these lines mean that in the relationship I need to store this foreign key. So we are not including new attributes for this relationship for the foreign keys. They are indicated by these links that are connecting the entity sets to the relationship. For example, in this case we have products in categories. So for a product we define or uniquely define a product by the product number, and for the categories we have category IDs. And in the product table, for example, product number 1 is water, and we have their prices, etc. In the categories we have, for example, drink, bakery, sweet, and toy. And for this relationships table, so for any of the entity sets and the relationships, they actually correspond to tables, and in those tables we can store data. And in this in table we actually storing two columns, and those columns are actually indicated by these links to the entity sets. So for finding the related product, I need to store the product number, which is the key, the primary key of the product table. And to be able to find the related category, I need to have its primary key, which is the category ID. And in here it is referred to as a foreign key. So actually we are relating products with categories using these two foreign keys. For example, I can relate product number 1 to category number 1. So we are saying basically water is in the category drink. And for example, we can relate 2 to 1, meaning soda is also in drink category. And for example, chocolate is in bakery, or it should be maybe in the sweet category. So the relationships have two additional details. One of them is the cardinality. It defines how much of one side can be matched with the other side. So it is indicated with arrow symbols, and when there is an arrow in the style that we are following, that arrow is going to appear next to the diamond shape, next to the relationship. So in some other ER diagram styles, the arrows can appear next to the entity sets as well. But in this style, if there is an arrow, it's always going to be next to the relationship symbol, next to the diamond shape. So we have three different kinds of cardinality. Many to many. If there is no arrow at all, then this means that for this example, for example, one product can be in multiple categories, and in one category there can be multiple products. So from left side it can be matched with multiple entries on the right side, and vice versa. On the right side it can be matched with many entries on the left side. There's the one-to-one relationships. Then we have arrow symbols on both sides, or it can be also, for example, if more than two entities are involved in this relationship, we can have another entity set here as well connected to this relationship that also can have an arrow. It's going to be like one to one to one, but now we are talking just about the two entity set case. In this case, it's going to mean that one product can be in at most one category. So for some products, maybe they are not involved in this relationship, they have zero category. But for some products, if it is involved in this relationship, it can be involved at most one time. So for a product, it can be matched with only one category, and for one category, there can be at most one product. So the cardinality is not saying something about whether any entry here should be in this relationship or not. But if it is in this relationship, it is saying that it is limited to at most one matching. So it can appear only once in this relationship. We also have the one-to-many case. For example, in this picture here, it is saying that one product can be in at most one category, and in one category there can be multiple products. So for example, if a product is going to be only in one category, this is going to be like the usual scenario that we are going to have. So for a product there can be only one category, but in a category there can be multiple products. So in this case, the arrow is on the side that is going to actually appear once in the relationship, but it can be sometimes confused, and to remember it, maybe this picture could help. For example, in this scenario, let's say one owner could have many dogs, but for a dog there could be at most one owner, let's say. And in here the leashes of the dogs kind of resemble the arrow symbol that's on the dog side. So in picture here we have owner has dog, and the dogs are many, right? We have their leashes, and they are kind of similar to this arrow shape which is on the dog side. So we also have the participation constraints for a relationship, and it's shown with bold lines. So if there is a bold line on any of the sides, then that means that the entity set that we have the bold line has to appear in the relationship. So for example, in here, if we are saying, okay, every product should be in at least one category, it is indicated with this bold line on the product side. So we are saying that if I have an entry in the product table, that entry should also appear in the table for the relationship in. So it can appear on both sides, meaning that every product should be in at least one category, and in every category there should be at least one product. We can also combine these with the cardinality constraints. For example, in here, if I have a bold line on product side, and if I have the arrow as well, so in here category is like the owner and products are like the dogs, right? Every product should be in a category, but it is going to be exactly in one category. But for a category there could be multiple products, and maybe in some categories maybe there is no product at all, because category does not have to participate in this relationship in. And going back to our description, it was saying that every student should have one teacher as their advisor. A teacher may be the advisor of many students. So we are only focusing on one part of the ER diagram, so the other parts are not shown here. So otherwise, user was the parent of the teacher and the student. But we are defining this relationship in between the teacher and the student, and it's saying that for every student there has to be every student should have one teacher as their advisor, exactly one teacher, not less, not more. So we have total participation on student side, and we also include this arrow to say that, okay, for a student that can be at most one teacher. Because of the bold line, it is also saying that it should be at least one teacher as well. So it is decided as exactly one teacher as their advisor. But then on the other side, a teacher may be the advisor of many students, but maybe not, right? There is no a necessity for a teacher to become an advisor. Then we have this simple solid line on teacher's side. Then in the description as well, it says for each course you should store a unique course code and an optional description. So this is something new, some new entity set we introduce into our diagram. We keep the course code and the description. It says the description is optional, but so far in the ER diagram we are actually we do not have the distinction about optional cases. So in the description we can have additional information related to the later stages of the project, but being optional is not represented in the ER diagram. In the ER diagram, what we show is what we are going to store. So we need to store a field for the description for a course. Whether in the real entry it is included or not is not a case for the ER diagram. So then we have in the description saying every course must be taught by exactly one teacher. On the other hand, a teacher could teach many courses. So we already had the entity sets for the teacher and the course. It is saying that there is some sort of relationship in between these two things. Every course must be taught by exactly one teacher. On the other hand, a teacher could teach many courses. Again, in this case, courses are kind of similar to the dogs. We have the arrow on the courses side. For a course, there's going to be only one teacher, but one teacher could give many courses. But every course, if there is a course, it must be taught by some teacher. Because of that, we have the bold line. We also have the ternary relationship. In certain cases, the relationship could be among two or more entity sets. It could be three. Most of the time we see it in the tree case. That's why it has this special name called ternary relationship. But actually there is not a limit on the entity sets that we can connect to the same entity, to the same relationship. For example, in this case, let's say when a teacher is teaching a course, we also need to assign a classroom for that teacher. So we have the class entities. For the teaching activity, we would like to assign the classes. In this case, we can use a ternary relationship, meaning that whenever we are teaching some course for a teacher, so we need to have a teacher, we need to have a course, we need to also have a classroom. In the relationship, we are going to store these three foreign keys. And with the cardinality and participation rules, they are kind of similar. For example, if I have an arrow on each side, it is going to mean that one teacher, one class, and one course is going to appear once. But for some cases, for example, this is also another example, how to read the cardinality. So in the basic case, what we have was the arrow symbols. And since we have just two entities, it was easier to read it. But then if we have three or more entity sets, how to read is going to be like, for example, if we would like to inspect what's going on in between classes and course, you can like hide the teacher side. So let's omit the teacher side. Then this is like a simple relationship between class and course. For a class, there could be multiple courses, but for a course, there is going to be only one class between the class and course. So let's omit the class side. In this case, a teacher is going to teach multiple courses, but for a course, it can be taught by only one teacher. If we omit the course side, then looking at the relationship between teacher and class, then a teacher can teach in many classes, and in a class, there could be many teachers teaching some course. So that's going to be how to read or find the cardinality of ternary relationships. But combining 4 different entity sets are not that common. So that's why the ternary relationship has a name, but the others does not have. And another option is the aggregate relationships. So with ternary relationships, we are, in this example, combining a teacher, a class, and a course always. So if we are teaching, we always have these 3 different things, 3 different entity sets coming together for the teaching activity. But let's say in the description, if it was saying teachers teach courses, and sometimes we need to assign a classroom for the teacher that is teaching the course, not always. So in this case, if we were to use this ternary relationship, for example, I'm assigning a teacher to a course and I need to assign the class as well, but maybe that's an online class. Maybe we do not need to assign the physical classroom for that. If I'm keeping null values for many of these entries, then maybe instead of the ternary relationship, what I need is an aggregate relationship. So aggregate relationships are actually defining a relationship on top of another relation. So in here, we have an existing relationship between teachers. They are teaching courses. And in the case that I would like to also introduce a classroom for this teaching activity, so I'm not giving the classroom to the teacher, and it is not for the course as well. So maybe there are some courses that are not taught in this semester. Then for those courses, I don't need to assign a classroom. And I also would like to avoid, by mistake, assigning a classroom to a course that's not being taught. So in this case, one option is to use the aggregate relationship. The in relationship is an aggregate one. It is actually connected to the teacher's relationship. But in the ER diagram, we do not show it like that. We are not directly connecting these to ellipse shapes. We actually have the dashed rectangle around the relationship that exists before. So teaches, this relationship exists before we combine this in relationship. So for the relationship and the entity sets that are connected to that relationship, we include this dashed rectangle. So we have that dashed rectangle and we connect the aggregate relationship to that dashed rectangle. And anything about participation and cardinality constraints, they still apply to that. So I might have arrows next to the relationships. I might have some bold lines according to the scenario. So existing relationship is inside a dashed rectangle that also contains the related entity sets. Whether you include the attributes as well or not, that's up to you. So to make it look good, it could be like any of them. But make sure that in the dashed rectangle, I should have just one relationship and the entity sets that are connected to that relationship. So there can be only one relationship inside the dashed rectangle. Actually, what we are doing is to connect the relationships together, but in the ER diagram, we show it differently. So in the description, it was saying that students can enroll in courses that are taught by certain teachers. In this case, you should store which student has enrolled to which course taught by which teacher, as well as a grade in the range 0 and 100. So in this case, we already had this relationship existing between a teacher and the course. So the teachers are giving the courses. But on top of that, for the teachers that are teaching some courses, we would like to enroll our students. So it can be like designed in a different manner as well, but to give this aggregate relationship example, we are combining it as an aggregate relationship. And for a student to enroll a course, we also want to store the grade. There is some condition for the range of the grade, but it's not again shown in the ER diagram. So in the ER diagram, we are not showing such constraints. So it's something for the later stages of the project. And in the ER diagram, we can also have weak entity sets. So for example, this is again from the description, it's saying that students can have medical reports. For each medical report, you should store a date and a description. Each student can have many medical reports. However, each medical report must belong to exactly one student. one student can have at most one medical report on the same date. So in this case, actually, we need to store medical reports, right, for the students. So we have this entity set medical report. But for a medical report, what we store is the date and a description. So if you consider, a date by itself is not going to uniquely identify a medical report, and the description is not, again, uniquely identify a medical report. We in the most real life scenarios, we need to have some sort of unique ID for a medical report, for example, some report number, etc., that's going to be uniquely identified. But in the example, we do not have such information. But then each student can have many medical reports, but each medical report must belong to exactly one student. So one medical report cannot belong to multiple people. One medical report can only belong to one student. For a student, there can be multiple reports, but because of that, since one student is going to have, since one medical report is going to belong to only one student, what I can do is, if I know the student's ID, then to uniquely identify a medical report, I can use that ID information together with the date. So for a student, if we are just looking at a student only, for that student, there can be only one medical report on the same date. So it is also given. One student can have at most one medical report on the same date. For different students, for example, Ali and Ayşe, they can get a medical report on the same exact date, but Ali cannot get another medical report on the same date. So that's our constraint. Because of that, I can define the date as the partial key to show that I have the underlined, the attribute is underlined with dashed line. And for the weak entity set, why it's weak? Because by itself we cannot find a unique entry. So for a medical report, the description and the date are not enough to find a unique entry. I need also the information about which student has this medical report. Because of that, we say that this is a weak entity set, and the relationship has is called the weak relationship to connect this weak entity to a strong entity. In this case, student is the strong side and the medical report is our weak entity, and the weak entity and the weak relationship are using tick lines for their shapes. So that's how we show a weak entity. In the description, it says users can send messages among themselves. In this case, one side is the receiver and the other side is the sender. You should store a text message and a date for each sending operation. Each sender can send to many receivers, and many senders can send to the same receiver. On the same date, a particular sender can send at most one message to a particular receiver. So this is not a realistic scenario for sending messages, but to give an example, we included that. So users can send and receive messages. So in the send relationship, the user is connected twice, once with the role of a sender and then the role of the receiver. So we have two lines for the same entity set, but we are using different roles. So the names of the roles are included here. So actually there is the question, if we delete one student, does the corresponding medical report also gets deleted? For the weak entity set case, yes. So if we have the weak entity, if we are deleting the student, for example, here on the strong side, then the medical reports that belong to that student has to be deleted, because otherwise we are not we do not have any access to those medical reports. So the related student, if we delete a student, the related medical reports get deleted as well. So coming back to here, we are sending and receiving messages among users. We store the message as an attribute. We also store the date for this send operation. And in this case, we said that let's say on the same date, the one sender can send at most one message to a particular receiver. For example, Ali is sending a message to Ayşe, and if it is today, then Ali cannot send another message to Ayşe on this date, but maybe tomorrow he can send. But Ali can receive message from others. Ali can send a message to others. So this is like not a realistic scenario, but for the sake of the example, for the relationship send, its foreign keys plus the dates are going to be the primary key. So for a message to uniquely identify a send operation, what we need is the sender and the receiver foreign keys plus the date. So date is another attribute that uniquely identifies a send operation. We are actually going to see more detailed examples of it in the next lab. But for now, let's just look at some common mistakes, because when we say, okay, let's draw the ER diagram, we have seen such mistakes. So to avoid them, we are not connecting attributes together. So for example, two attributes cannot be connected to each other. Attributes are connected using tick or directed lines. So while, they cannot be connected using tick or directed lines. So we always use the simple lines to connect an attribute to a relationship or to an entity set. So there is no arrows or bold lines there. The arrows of the relationships, they are always appearing next to the relationship symbol, not towards the entities. So there are some different ER diagram styles that are using this, but in this style that we are going to use, that's not a notation. So dashed rectangle cannot contain more than one relationship. So in the aggregate relationship case, we are actually connecting the relationship that's outside the dashed rectangle to the relationship that's inside the dashed rectangle. But if there are multiple relationships inside this dashed rectangle, we do not know which one to connect to, right? We need to have just one single relationship inside the dashed rectangle. And also the partial key of the weak entity, it is not going to have a solid underline. The solid underline means that it can uniquely identify an entry by itself. No, in this case, for the weak entities, there is no primary key. There is only the partial key. It is used with the related strong entities key, right? In the student case, I need to know the student's ID plus this partial key to find unique medical reports. So for weak entities, the partial key should have the dashed underline, not a solid underline. A weak entity cannot depend on another weak entity. For example, if I say, okay, for this medical report, it is also going to contain an address, but it should depend on a strong entity, right? And if address is also a weak entity, we do not have a strong entity in this case, so we cannot have such chains of weak entities connected to each other. So a weak entity that depends on a strong entity should be connected to a weak relationship. So if I have a weak entity, I should also have the weak relationship. Both the relationship and the entity set should have the bold lines. Otherwise, if one of them is just bold, it's a notation mistake. So in this case, has relationship should have bold lines, and in this case, the medical report entity set should have the bold lines. So in the next hour, so we are going to give a 10 minutes break now. We are going to create this diagram shape in Draw software. So if you have any questions, you can ask. Otherwise, we are going to continue at 4:30. Okay, any questions before we start? So in the labs, actually, they are kind of like tutorials, and you don't need to finish something and upload it to somewhere. So it is just like a tutorial, and you have the chance to, for example, try and ask if you encounter any problem about the software that we are going to use. One thing that you can do is to first you may listen, since these are recorded, and then you can try to do the same thing on your own in your free time. Then if you encounter a problem in the next lab, you can send us emails as well. So you don't need to finish something on computer during the lab. So on the website there is also, let me show. So this is the slides that we used, and there is also this handout. So handout is from earlier terms. So this is like the content of the lab 1. So we have some examples here as well. So it is actually using the same example scenario. It has more description. So this is like a reading material. So instead of having the slides as a summary, it also contains some screenshots and information about using Draw.io. And now we are going to use Draw.io. So this handout is for your own reading if you want to read. So for drawing ER diagrams, if you look at the lab homepage, we have this Draw.io online tool. So there are some other tools specifically used for drawing diagrams as well. But Draw.io is a simple one, and it can be used for any general diagram. Therefore, it's actually useful whether you are drawing an ER diagram, maybe for some project you need to draw another diagram. It's a useful tool to know how to use, and it's actually simple. I'm going to just show how to use it in example cases. So if you open that website, it's going to first ask, if it is the first time you're opening this website, it's going to ask where you want to save your diagrams. You have a bunch of cloud options as well, but let's say I'm going to save it to my device. So you can open an existing diagram, but in this case I would like to create a new diagram. There are some templates for diagrams here, and there is actually one ER diagram here as well, but it's not following the style that we are going to use in the class. So this is using a different style of ER diagrams, therefore we are going to go with the blank diagram. And in here, so we can give a name to our diagram, and the extension is going to be .draw.io. So let's say this is lab 1. There is also some other formats, so the one that we are going to use is going to mostly be the Draw.io format, but if you are using some other formats, you can also edit them as well, but let's go with the Draw.io formats. So I'm going to create this. Since I choose my drive, it's going to ask a folder to save this diagram. So I'm going to write the same name. This is going to lab1.draw.io. There is also the installable version. So right now we are using the online version. So you can use the online version, and it also gives us here the chance to install the software version. So for some major operating systems you can download it as well, but you may use with the same functionality the online version. When we open, we have our toolbox on left. So we have some shapes here, and under view we can open and close these panels actually. So this one can be hidden, so if it's hidden you can show it. We have some panel on the right side as well, so based on the context that we are using they might open up, but if they are hidden, the right one is called the format panel. This button is going to hide and unhide it. The left one, actually I guess you cannot hide that one, so the left one is always there, but it might be resized. So if you need to see that, you just need to drag your mouse and make it larger. So sometimes people by mistake close or hide things, so that's a way to get them back. So in here in Draw.io we have some shapes. So for example, let me just click on the rectangle. I can bring that rectangle into my scene. To move it around, if I click with the mouse left button and then drag my mouse left button, if I move the mouse, then I can drag it. Like, these are very simple controls that you are probably accustomed to. While as shape is selected, I see some blue circles around it on the corners. If I click and hold using one of those circles, I can resize this shape. Another option, I can rotate shapes, but in ER diagram we actually don't need to rotate shapes, so that's something for other usages. And while a shape is selected, if I start typing, then the text is going to appear on top of the rectangle. For example, let me resize it. I have the zoom in and zoom out buttons here. If I hold the space bar, the space key on my keyboard, I can click and hold my mouse left button and I can move around the scene. If you have a mouse wheel, then clicking on the mouse wheel is also going to let you move around the scene. If you hold the control button on the keyboard and use the mouse wheel, you can zoom in and zoom out from the scene as well. So I'm going to use these, and if you like, for example, actually zoom in and zoom out buttons are here, but if you keep your mouse over them, it's going to show the tooltip. So for example, Control plus numpad slash is going to also zoom in, but another alternative is pressing and holding the Alt key on the keyboard and using the mouse wheel. It's another option. Actually, with Control as well, you can do the same thing. With Alt key, you can zoom in and zoom out as well. So this is one shape. So if I click on another shape, it's going to bring that shape here as well. I can, for example, type something else on top of it. Maybe let's say I would like to change the text of it. If I double click on it and then click once more, I can here edit the text that exists. If I right click on any of my shapes, I have the option to copy. For example, I can copy and paste using the right key. So I can use the keyboard shortcuts as well. Control C for copying, Control V for pasting. I can drag and choose multiple items with the mouse. I can use the delete key to delete the existing or the selected items. So while a shape is selected, if I start typing again, it's going to replace the text. And for each selected item, if I right click on this format panel while a shape is selected, so if nothing is selected, this format panel is going to show some options about the page. So I really don't need to change the options for the page, because if I go out of the page, for example, it's going to automatically have multiple pages. So I don't need to really worry about the space in Draw.io. But for the shapes, for example, if one shape is selected in this format panel, I have some styling options. I can use colors, etc. for our other general cases, but in the ER diagram, what we need is going to be, for sometimes we may need the underlined text, right? So for example, if I create an ellipse shape, maybe this is our attribute. Let me resize it. And to underline the text, under the text option, I have the underlined text. I can use that one. So another option, sometimes we need to make bold lines while a shape is selected, or sometimes we can also make the bold arrows, for example. But for now, let's do it for the rectangle. While the shape is selected, under the line, I have the color of the line, and I also have the width of the line width. If I make it thicker, it's going to have the thick lines for my shape. And after I change the style, if I introduce a new item, that new item is also going to follow the same style. So anything new I bring is going to have the thick line. So I need to be careful about that. For example, I made it thinner, then any new shape I bring is going to have the thin line. So this is online, remember. If I want to save under file, I have the save option. Control S is the shortcut, and it's going to save on the file that you created. So in the folder that I choose, it's going to download and update that file. If I need to save it as a different file, I have that option as well. Another option is to export an image file out of it. So in the project, you are going to upload the Drawware file, but in Homeworks, for example, you may need to export it as an image. Then you can choose, for example, to export it as a PNG, for example. Then this zoom option is actually determining the resolution. So I can export it with 100. So if I export it, I have the option to save it to some place. Let me just open it in a new window. So this is the image file, but the resolution is low. So if you need a higher resolution, what you can do is, while exporting, in here you can write the zoom number high. So whenever I export, let me just open it in a new window. So this is going to be in much bigger resolution, so the text will appear better in this case. So that's if you need to export it as an image file, that's one thing to note. Then we need to connect these items, right? For that we are going to use lines. So line here is another shape, and with lines we can connect them to the existing shapes. So lines have two endpoints. So while a line is selected, I see those endpoints, and from one endpoint I can carry the line. I can carry the line by itself as well. So usually we would like to carry them from these endpoints. And if you move on top of another shape, maybe they are not very visible, but there are some anchor points shown with X marks around the shape. So for example, if I drag and drop it into the center of the shape, then this line is connected to that shape, and whenever I move that shape, the line is also going to move accordingly. So if I drag and drop it on top of the middle of the shape, then these are connected and the line connects them in a smooth manner. Another option is to connect the line to a specific anchor point around the borders. So if I connect it to the top anchor point, for example, then it is going to be connected to that anchor point. So usually we would like to carry the line into the middle of the shape so that they are connected to the center, through the center. So for now, let me just get rid of these ones, and I would like to create this ER diagram that we used for our example, and it has all the different types of shapes that we are going to need for the project. So I'm going to keep it on some part for myself, and I'm going to create it in Drawware from scratch. So a good part to start is going to be the parent of some entity set. So in the diagram, if you remember, we had users, and teachers and students were types of users or child of user entity sets. So I'm going to create a new rectangle shape, and for this one it is going to be the user entity set. So I can resize it to fit the items together in a better way. And most of the time, for example, let's say I have an entity set and they are going to appear in more or less the same size. If I were to create a new rectangle, I need to resize it again. I'm going to use the Control Z to undo. So there are also buttons to do that here. So instead of creating a new rectangle, what I would do is to duplicate, to copy and paste this user. The Control D hotkey is used for duplicate. So if you right click, there are also the menu items to do those operations. So if I duplicate the entity set, then it's a copy of that. I can just click on it and make it for the teacher, and I'm going to duplicate this one, and this time it is going to be for the students. And while you are positioning these items, if it is in relation to some existing item on the same line, etc., it is going to show some guidelines. So for example, if these two are on the same line, it's going to show that blue guideline. And for example, maybe I may want to keep teacher and student on the same alignment, for example. So these are to make the diagram more readable. So between user and teacher and student entities, we need to have the is a relationship. And to do that, I need the equilateral triangle. So I'm going to click on that. One thing to notice is that here it's not pointing upwards, right? We need to have the triangle pointing upwards. So I need to rotate it. So one thing to be careful about rotation is that, so for example, if I type something here, so if I click on this rotation symbol and left my mouse button, it's going to make 90 degrees rotations, and it's going to keep the text aligned. But if you click and hold the rotation symbol, it's going to rotate the text as well. So that's just one single thing to be careful. If you don't want to rotate the text as well, just click on the rotation symbol, or alternatively, while that shape is selected under Arrange in the Format panel, we have this Rotate Shape by 90 degrees. So this button, you can also use it for rotation. And with is-a relationships, what we need to do is to write is-a on top of the triangle shape. And maybe I can like go to the next line here to make it more centered. And let me resize it. So I need to connect the lines. For the user, it should appear on top, right? I'm going to bring a new line here, and I'm going to connect it to the user. And this part, actually, instead of connecting to the center, so with the is-a relationship, I need the parent to appear on top, right? If I connect it to the center anchor, then maybe while designing, I might put the user into a different position, and then it may look like as if it's the child of this relationship. So to avoid that, what I will do is going to be to connect it to the top anchor point. Therefore, if I move it around, then I still know that the user should be the parent. So just for the is-a relationship, maybe it's a better idea to use the anchor points around the shape. So I'm going to duplicate this line with Control D, but for the others, for the entity sets, I'm going to connect them to the middle anchors, but for the lines that are below the triangle, I'm using the bottom anchor points. So then, for a user, I need some attributes. I'm going to bring an ellipse shape. So I need the ID of a user. So let me resize this. I also need the name of a user, Control D to duplicate, and then I just type the new data, right, for the surname. So maybe for this one I need to resize. I just click on the item, make it bigger. I also need a password attribute. So maybe for this one as well, a little bit bigger. And these are the attributes of the user, and they should have a solid line connecting the attributes to the entity set. So I just use different copies of the same line to connect the attributes to the user entity set. And in here, the primary key is ID. So for ID, it should be underlined. One option was, while this shape is selected, I can go under the text and choose the underlining, but the hotkey for that is Ctrl+U. So from the keyboard, I can also use Ctrl+U to make the underlined text. So we have courses, right? So actually for the student, we need to keep the scholarship amount. So an additional attribute, we connect it with a solid line. But we have also courses, so this is going to be a different entity set. And for a course, we need two attributes. One of them is going to be, so let me put it here. One of them is going to be the course code. So it is going to be the primary key of this table. I need to underline it, Ctrl+U. And I also need the description. which is an attribute for the course entity. So if it belongs to the course entity, I need solid lines to connect that. And then I need to have a relationship between teacher and course. So we need the ellipse shape. I introduce the ellipse shape to the workspace, and my relationship is going to be called gives, or maybe teaches, etc. So if I want to align course with the teacher, so while I'm moving it around, I will see the guideline, the blue guideline that connects it to the teacher. For the gives relationship as well, I can like find the center to align them in a better position. So with the relationships, we start with the basic lines, but according to the cardinality and participation constraints, we might have arrows or bold lines that are connected to the relationships. So on the course side, remember, one course can be taught by only one teacher, but on the other side, a teacher can teach many courses. We need the arrow on course side. So to put an arrow, while the line is selected under the style, so remember again, this is under the format panel. If the format panel is not open, I'm using this button. Under the format panel, I have some options for the line, and one of them, so these two, are for using symbols at the starting and ending positions of a line. So one thing to notice is while we are like moving the line around, it's not easy to remember which side is the ending and which side is the starting point. So we will just choose the arrow side. So this is for the starting and the other one is for the ending. But while positioning the line, we don't know which one is the starting and which one is the ending point. Just choose a random one, choose the arrow for that. So by chance this was the true one. But if it is the wrong one, so let me choose the other one. So in our notation, there is no such notation like that, right? I need to reverse the arrow. The arrows, if there is an arrow, it's always next to the diamond shape. So to reverse it, just right click on the line, and in here we have the reverse. The hotkey for that is Ctrl+R. So using Ctrl+R, I can just reverse the arrow so that it points to the correct side. So that's one thing. And I need to make it thicker, right? We had total participation on course side, meaning that every course should be taught by some teacher. So while this line is selected, for the line width, I'm going to make it thicker. So we had also an enrolled relationship. It was defined on top of the gives relationship. We need to use the aggregate relationship. So let me first start with the diamond shape. So we have the enrolled relationship, and it is going to be connected to a student and also a teacher teaching or teacher giving a course. So we would like to connect it to the activity, to the relationship, not to a teacher, not to a course, but this relationship. And in our notation, we cannot combine the relationships together. So this is not the notation. And if we need to do that, we are using aggregate relationships. The aggregate relationship requires a dashed rectangle around the existing relationship. So I'm going to create a new rectangle shape. But there is layering in Draw.io. So any item that I introduce later on, they are actually in front of the existing items. So this is actually in front of the existing items. So one option under style, I can remove the filling, so it becomes an empty rectangle, but it is still over the existing items. So if I try to choose teacher, it is going to choose actually the outer the rectangle that's on top of them. It's not filled, but while trying to select it, it is going to select the one that's on top. So instead of that, I'm going to keep the filling. I'm going to right click on this rectangle shape and I'm going to send it to back. So if you choose to back, it's going to place it to the farthest back layer. Then, for example, if I want to choose teacher, I can easily choose that. If I need to choose this outer rectangle, I can also from some point of that rectangle, I can choose that as well. So what I need to do is for this rectangle to cover the relationship and the entity sets that are connected to that relationship. Whether I include the attributes as well or not, it's up to me. So this can be okay as well. So it's for you to decide which one looks better, more readable. You can choose that one. But what I need to do is to make it dashed, right? So while this new rectangle is selected, I need to go to this panel and underline. We have the style of the line. So this is the solid line and we have the dashed line. So I'm going to choose the dashed line for this one. And I need to connect it to the enrolled. This is another shape. I can just connect it to the shape. And for enrolled, I also need the grade. So I'm going to just have a copy of an attribute for the grade. And I also need a line connecting this to the enrolled relationship. And then I also have my weak entity set. So if you remember, we had medical reports. So we have medical reports, which was a weak entity. So to show that this is a weak entity set, what I need to do is to make the shape thick, right? For this medical report under this panel, for the line width, I make it thicker. For this one, I have a bunch of attributes as well. I need the description and I also need the date. So these are the attributes of medical report. I need to connect them using the simple lines. So entity for attributes, we always use the simple line. So for attributes, there is no tick arrows, tick lines or arrows. We always use the simple line. So there is a question, is there a way to edit teacher or course entities while they are in the aggregation rectangle? Yes, of course. So these are actually not aware of this dashed rectangle. So the dashed rectangle is just one shape that we included behind these shapes. So they are actually not really in it. And while carrying it around, to keep them inside, I need to choose them as a whole. So if I choose them together, then I can move them around. But if I need to, for example, change the name here, I can just go and change those names. But one thing maybe, I was unable to do that, you say. Maybe if you group them, so if you choose multiple items, there is the option to group them. If you do the grouping, then you cannot edit them directly. You need to like double click and go inside that group. But with the grouping, you can like carry them more easily. But maybe what you did was okay, let me undo a couple here. So I'm just going to ungroup them again. Maybe what you did was maybe you removed the filling and maybe this was at the front. So that might be the case. So if this is at front, then you cannot choose the items that are behind them. So remember, there are two ways to make the dashed rectangle appear covering the other shapes. One was to send it to the back, then you don't have any problems for choosing. But the other option was to remove the filling. But if it is in front, then you cannot choose the ones behind. So you may need to move it aside to choose the other ones. But the better option was, instead of removing the filling, just send it to the back. So then they are still editable. Okay. So with the medical report, it was our weak entity set. Let me actually first maybe get the weak relationship here as well. So I'm going to choose multiple items, move them aside. So for this relationship, our weak relationship was saying has on top of it. I replace the text. I'm going to make this item thicker. So while it is selected under this panel, I just increase the line width. I need to include my lines. So student is connected to this relationship has. and the medical report is also connected to that relationship. And with the weak entities, we usually have total participation on the weak side. So if we think about it, so with the weak entity set, what we were saying was, to define a unique medical report, I need to know the information about which student it belongs to. Because of that, every medical report should participate in this relationship. I need to have the tick line on this right side. Why? Because otherwise, if this medical report belongs to no one, then there is no way to find a unique medical report there, right? We are using the strong entity's primary key to identify a unique medical report. On top of that, I need the arrow for the medical report side. I'm going to choose the arrow. It's on the reverse side. I need to use Ctrl R to reverse it back in the correct position. I need to have the arrow. Why? Because for a medical report, it should belong to only one student. If it belongs to multiple students, then I don't have a way of identifying a unique one. So for example, for the medical report on this date, the date of today, if it belongs to two different students, then I'm not able to distinguish them, right? Because to distinguish a medical report, I need the student's ID. But if the medical report belongs to multiple students, then there is no way of identifying a unique one. So because of that, for the weak entities, we almost always have the tick arrow on the weak entities side. So this is like a picture we mostly have for weak entities. And for the date, this was the partial key. I need the dashed underlining. So unfortunately, there is no dashed underline directly for text. So there is the solid underline, but remember, we cannot use the solid underlining. It's not a strong key, it's just a partial key. Because of that, we are going to just include a dot line here or a dashed line. So I'm going to bring a dashed line. So since the last item that I made was using a tick line width, so this is also a tick. Under style, I'm going to decrease the line width, and then I would like to connect it to this shape so that it appears as if it's our underlining. So I'm going to use the bottom two anchors. So remember, there are some anchor points around the shape. If you use that anchor points for this line, if you are to move the ellipse shape, then the line is going to also follow. One thing by mistake you can do is you can just put it on there, but it's not connected to the anchor points. Then it makes our lives harder, right? When I move the shape, I also need to move the line. So while for this partial key underlining, just use the bottom anchor point. So one and to that bottom left anchor point, and the other one to the bottom right anchor point. Then whenever you move the ellipse shape, then the line is also going to follow that shape. So we are also left with the sand relationship. So I'm going to bring another diamond shape here. For the sand relationship, we need to connect it twice to the user entity set. So I need a line connected to the sand and user, but if I duplicate the line and if I try to use the center anchors, then they are going to appear on top of each other. So if I need to connect it more than one, then it is better to use the specific anchor points rather than to connect it to the center point. So with this one, I can have them appearing separately, and I don't have any problem moving them around. So for this one, we need to also define the roles, right? While a shape is selected, I can type on the keyboard, and it is the same for lines. So one side is going to be the sender. I just select the line and type on the keyboard. So my text appears here, and the other side is going to be the receiver, but they are on the same line. So I can choose the text, and you will see yellow dots next to the text, by holding and moving that yellow dot, you can position the text. So whenever you move the item, the text is going to follow in relation to that point on the line. So for this one, we also need the message attribute, and we also need another attribute called date. And remember, date was also the part of our key for the send relationship. We are actually in the ER diagram. So for this one, we need the underlining. So in the ER diagram, for every entity set that is not a child of a parent, so for example, in this case, these are the user table, the user entity set, the course entity set. So for these two, I need to have a primary key. So for the user, I have the primary key. Primary key can be a composite one. So it can be the combination of maybe ID plus name. So there is that's going to be determined according to the description. So the description might say, okay, users are identified by the combination of the ID and the name, for example. That might be the case. Or maybe it's saying the users are identified by a unique ID, or maybe it's just saying that the ID is unique, and while determining a primary key for this table, you might decide, okay, ID is already unique, let's make it the single primary key of this table. And in the course, for example, the course code is our primary key. So if I don't have a primary key for such an entity set, I have no way of finding a unique row in that entity set. So for every entity set, I need some primary key. But one difference, or one detail, is that if some entity set is the child of an existing one, then it is going to inherit the attributes of the parent. So teacher already is going to inherit ID, name, surname, and password from the parent. Therefore, I don't need to define or show this teacher's primary key explicitly in the ER diagram, because it's already implied by the parent's ID. So I know that for teacher as well, I'm going to store ID, name, surname, and password, and ID is going to be the primary key of the teacher. For student as well, the same thing. Just additionally, I'm storing the scholarship for a student. And for weak entity sets, we are using some partial key. So for the weak entity sets, instead of a primary key, we use the partial key. For relationships, we are not explicitly showing any primary keys. So this enrolled relationship, actually, it is going to correspond to a table as well. So while we are looking the slides, so let me bring it here. So if you remember, while looking at the relationships, we said that, okay, in this relationship, we are also going to store some data. It is like a table. But in the ER diagram, we are not explicitly talking about the primary keys of the relationships, but they will be determined by their foreign keys. So in the next lab, we are actually going to see it in more detail, but it is just for knowing it for this lab. So for relationships, when we convert them to tables, there are going to be primary keys, but these are not explicitly shown in the ER diagram. They are implied by the foreign keys. So enrolled is connected to student, therefore it should have the primary key of the student. But the student's primary key is actually inherited from the user table, for example. And for the other sides, enrolled has a foreign key that is going to reference the gives relationship, and what is the primary key of the gives relationship is determined by the links to the entities for the relationship, for the gives. I'm saying that because for the send relationship, actually, on top of the foreign keys, I also need to use dates as a part of the primary key. So the thing that I would like to say is that for relationships attributes as well, you might sometimes have underlined attributes. That means that it is going to be a part of the primary key, but date itself is not the single attribute of the primary key for send relationship. Actually, the foreign keys, these links towards the entity sets, are going to be also included for the primary key of the send table. So far in the ER diagram, we are just showing our design. For the foreign key concepts, we are going to introduce them in the later labs, and in the ER diagram, they are actually implied by the links between the relationships and the entity sets. But this is just to be like to be informed. So sometimes we might have some underlined attributes for the relationships as well. So if you look, I guess we completed all the items here, and actually we have the advisor relationship in between a teacher and a student as well. So I need the advisor relationship here, and be careful, I should not include it in the dashed rectangle. Okay, can you show how to do a dashed underline again? So to do the dashed underline, what we did was, so for example, this is my ellipse shape. Since I changed the style of the shape to the dashed one, I need to correct it back. So I brought a new ellipse shape. I'm going to make it thinner, and for the line I'm going to choose the solid line. But if it is the first time we are introducing the ellipse shapes, for example, if we didn't change any shapes, etc., it is going to be in the correct format from scratch. But let's say we type something here and we would like to make the dashed underlining. To do that, we brought a dashed line. So under our shapes, we created a dashed line, and we are going to connect this dashed line to the anchor points for this shape, for this ellipse shape. So I'm dragging one endpoint to the bottom right anchor, and I'm going to drag other endpoint to the bottom left anchor. So these are like anchor points. For example, on top left as well, I have an anchor point. I can put it like this, and whenever I move the shape around, it's going to also move the line. But for this other endpoint, I'm going to use the bottom left point. So whenever resize if I move it, it's going to follow, and it will look as a dashed underline. So that's how we made it here. So I need to also delete the dashed line. So for the advisor relationship, one thing to be careful, it should not be inside the dashed rectangle, right? Because it's not a part of this aggregate relationship. So if I move it like that, then there is going to be a problem. The problem is I don't know which relationship enrolled is going to be defined on top of, right? The advisor relationship should be outside the dashed rectangle. So I'm going to maybe move it around, and we can like put the advisor here. And for the advisor relationship, what we needed was a tick arrow on the student side. So I'm going to choose the arrow head and make the line thicker. And let's check it again. I guess that's it for this diagram. So we are not missing anything. So then what I need to do, I'm going to save it, right? And it's in the destination that I chose. And if I were to, for example, let me actually maybe go to the, if it was not saved, it is going to actually say that you did not save, just be careful, etc. So if I go to the Draw.io link again, going back to this website, I have the remember option to open an existing diagram. And if I choose one, so this was for the lab 1, if I double click on that, I'm able to continue designing on this file. So you can save it as, you can use the cloud saving options as well. So we actually, for the project, we don't require you to export it as an image file, but for the homework, one of the homeworks, maybe you may need to draw an ER diagram, and for that you have the option to use Drawio as well. And in that case, you might need to export an image file from here. Any questions or problems about these? So actually, using Drawio is simple, but you need to be just careful about some little details. And the slides actually contain some information about our ER diagram usage. And in the project, you are given such descriptions, right? So you are forming your groups, and today, after the deadline, we are going to like determine the groups. Like mostly, you get the project that you want. So the project topics are weighted equally. They are very much similar. They just have they are just from different concepts or domains. If you didn't find a group after the deadline, we are going to assign you to either existing groups, or we might form new groups for you. So for the ones who do not have a group, like you don't need to do anything if you are not able to find a group. We are going to assign you to groups. And then the first step of the project is going to be to draw the ER diagram according to your description using Drawio. And for that, some of the parts in the description may not correspond to the diagram directly. In here, remember, it was saying that the grade of the student should be in the range 0 to 100. But we do not show this information in the ER diagram. So just remember, some parts of the description may not be directly converted to some part inside the ER diagram. They are more about the later stages of the project. And then you are going to get some feedback, and we'll have chance to fix the mistakes or problems in your ER diagram. So at every stage of the project, you are going to get some feedback, and we are going to like help you to be on track. Any questions, problems? Other than that, that's going to be it for today's lab. Actually, on the website as well, if you go to the lab homepage, there is also the ER diagram file for the finished version for this lab. So you can download this finished version from there as well. Other than that, that's it for today. So if there is no question.
May I say something? We don't need to send you anything for this step right now, right?
About the project or labs?
Labs.
Okay. For any of the labs, you don't need to like send anything. So all the labs are going to be like tutorials, and for the parts that we are using the software for the program, you might like try it on your own, and like if you encounter a problem, you have the chance to like ask us something, and these things that we introduce in the lab are going to be like evaluated through the project. So you are not going to upload anything for any of the labs, but we are going to like evaluate it somehow through the projects, because each of these concepts will be like a part of the project.
Okay, thank you.
No problem. Any other questions, problems? So then that's it for this lab. See you later.
See you.
See you. Görüşürüz.